Hello everyone. In this current session, we are going to discuss on a very popular and important Python library, that is Pandas. Okay. So, introduction to Pandas. Pandas is a Python package. It provides fast, flexible and expressive data structures. Okay. We can work with both relational and level data. We will come in detail when we will explore the examples. It has two main data structures. They are called series and data frame. Okay, we will have some examples with both series and data frame, how to use it. I will show you. Index objects enabling both simple access indexing and multi-level hierarchical access indexing. Okay, how the index works, that also I will show you. Okay, NaN is a full form is not a number, is the standard missing data marker used in Pandas. Missing data marker means, suppose as you have already used in SQL, so when there is no value we put null. Similarly here, if any cell of this data structure has no value, then it is represented with nan. Okay. So, as I told you that the main data structures in Pandas are series and data frame. So, series is a one-dimensional labeled homogeneously typed array. It means that it will have only one dimension and it will have the same type of data in the array. Okay. Time series, it is a series with index containing date times. We will use some of these also in our examples. And then comes data frame, very important one. When we are going to access files, usually we will use this data structure. It is a general two-dimensional labeled size mutable tabular structure with potentially heterogeneously typed columns. Okay, so I can have columns with different data types. So it is, you can think of it as a SQL table. As in database we have used tables, and tables has rows and columns, and there can be different columns of different data types. It is the similar kind of structure in data frame. Okay, data structures are value mutable but not always size mutable. So value mutable means we can change the values but not always size mutable. Okay, so the first one is series. Series is capable of holding any data type including integer, string, floating point number, Python object, etc. Axis levels are collectively referred to as the index. So you understand that it is as it is a one dimensional array, so it has one axis, single axis, and it is referred to as the index position. Data can be Python dictionary, ND array, or simple list of scalar values. Okay, that is how we create series. Next one is data frame. It is a two-dimensional label data structure with columns of potentially different types, as I told you. Here I can have different types of input data, that includes dictionary of one-dimensional ND arrays, list, dictionary or series. Then I can have this ND array, series, or even data frame as the input data. Okay, as you understand, it is a two-dimensional data structure, so it has a row and column structure. So row level is known as index and column levels are known as columns, and we can pass these arguments. It is optional. I will show you how it works. So whenever we are creating the data frame, we can send the input data, the index and the columns. Okay, so this is visualization. I will come to it later, but for now I will go to Jupyter Notebook. Okay, so this is Jupyter Notebook. Here I have opened this file. Here I will use this Pandas library and do some hands-on for better understanding. So the first block of code, here you can see I have imported these two libraries. NumPy we have already covered in our earlier session, and now I have imported this Pandas library and I have given the name as PD, short form. Okay, so I will first run these two statements. So it is executed. The next one is I have written s equal to pd.series. So now I am creating a series, and inside that series I have put a list of integer values. So this is one way that I can create series. So if you execute it, so you can see here that these are the list of values and this is the index. Okay, if you remember, whenever we create array in the standard conventional programming languages like C, C++ also, the index always start with 0. Here also for series the index starts with 0 to 4 and the values are 1 to 5, and D type means the data type of the values, which is integer. So I guess it's clear so far. Next one is dictionary. Here I have created one D named dictionary, and here I have 3 value pairs. Okay, key value pair. So if you remember dictionary structure, so this is a key, this is a value. So I have created one dictionary, and in the next statement I am creating one series named S1, and in this series I have passed D as the argument. So in this first example I have created the series from a list of values, and in this example I am creating series from a dictionary. So let us see how it works. So here you can see these values are coming as values in the series, and the key values are coming as the index of this series. So that's how the series object is created from the dictionary. Okay, so the next one, now you can see one difference from this first statement. Here I have created this series only passing the dictionary as argument, but here when I am creating the series I am passing D, but there is another argument. Here I am putting index equal to, and in bracket I have written B, C, D, A. Okay, so let us see how it works first. So you can see here, now B is 1.0, C is 2.0. So it's like the values are same but the order has changed. Okay, B, C, A. But in this dictionary there was no D, right? There was no key named D, but here I have mentioned one index as D. So in the value position for index D I have this NaN. That means I have created these 4 index positions and the values from the dictionary are placed here appropriately, but as for this D index there was no value in the dictionary, it is populated with NaN. I told you that it is as whenever there is no value for a particular cell, it is filled with NaN when we are creating the Pandas objects. So for any series I can always print the data type of that series. So if you print, you can see for S it was int64 and for S2 it is float. You can see here that when I have not mentioned any index, then it had taken simply the value from here and made it a integer series, but when I mentioned the index, then by default it has taken the values as float. Okay, so as you can do this indexing and slicing in that we have already discussed when we have discussed NumPy arrays, here also in series I can use both indexing and slicing. So here you can see I am printing different index positions for S0 for instance, then S2, second position of S2, and then in the third statement I am doing from C to A. C to A means for S2 it is B, C, D, A. So I just want to print from C to A, and then I have the slicing from 0 to 2. 0 to 2 means it will take the first index position as inclusive and second one as exclusive. So let us first execute this and check how it is working. So you can see S0 means it is S0 means 1, so it is coming as 1. S2 of 2, second position, so second means in S2 0, 1, 2, so it is actually the index position D, value is NaN, it is coming that way. And then for S2 I am printing from C to A, so it has printed from C to A values. Data type is also mentioned here. and when I am printing for S2 from 0 to 2, so 2 is exclusive, so actually I am getting for index position 0 and 1, two records I am getting. Okay, so I guess it's clear so far. Okay, in the next block of code, the first statement you understand, here I am just simply printing the series. The second statement, here I have written S3 equal to S into 2. It works similar to our NumPy, that if I simply write S into 2, it means that all the elements of that series should be multiplied by 2. Then I have printed, I have checked that how it works, and in the another statement I am doing S4 equal to S plus S3. It means it's kind of an array addition. So it is the series S and series S3 are added. That means the elements in the same positions should be added. That's my purpose. So let us execute. So this is S. This is the original S series. Then I have S3 equal to S into 2. So if you check, here this is how the S3 is printed. So you can check here, it is 1 into 2 2, 2 into 2 4, 3 into 2 6, and so on. So all the elements have been multiplied by 2. The next one is S4. It should be S plus S3. So if you see here, it's 1 plus 2 equal to 3, 2 plus 4 equal to 6, 3 plus 6 equal to 9, and so on. So that's how I can do this basic arithmetic operations on the series elements. Not element wise, but simply giving the name, I can do this addition, subtraction, multiplication, etc. Okay, now I have created one object from the Pandas, that it is a date range. So this is something different that I have used so far. So I have used series, now it is a date range. How it works, it also creates an array like object. Here I have given the date as the argument, the starting date as argument, and then I have written periods equal to 6. That means that there will be 6 elements array will be created that will start from this date and the next 6 dates. So if you print this, you can see it is called date time index. It's a special type of object is created and it's kind of a list. So it has this 6 date values. You can see here that it has started from 20th March and so on. So 28th March, 21st March, 22nd, 23rd, 24th, 25th. So 6 dates starting from 20th. Okay, so here the data type is date time and frequency is D. Frequency is D means the frequency is the date wise frequency. So for each date one value is created. So that's how I have created one array of values. Then here I am creating one data frame object. Okay, in bracket I have put this is a from np array. I am calling this function. It will generate 6, 4, that means 6 into 4, 24 random values, and its index is dates. Okay, so the first data frame object I am going to create, as I told you, that it will take the list of values as argument, the input data, and 2 more arguments. One is the index. If you remember, for series also I have put index. I can put index, right? Here I have put index for series. So for data frame I put index and columns as well, because it's a 2-dimensional array, right? So if you just print it, let us see how it works. So now you can see these dates have come as the row levels. Okay, that is called index. And here in the columns I have put the list of ABCD. So A, B, C and D have come as the column list, and these are all the values, means 6 by 4 total 24 values, which are random numbers generated from this NP functionality. So that's how this DF is created, the first data frame object we have created. Okay, this is another data frame object. So let us first execute it, then I will explain you how it is working. Okay, so if you print it, okay, that is how this df2 is created. So it is, you can see in data frame I have passed one dictionary object, and it has actually different types of elements. So for this dictionary, A, B, C, D, E, F are the key values. So these keys have come as the column levels, okay, and these are the values. So for first column A, the value is 1. So you can see here, first column A, all the values are 1.0. Okay, the next one is pd.timestamp this. So timestamp is another type of object that you can create. So it is a kind of a date time object. So you can see for B column I have all the values as 2019 320. In C I have, in the dictionary value, I have a series which is having the value 1, and the index position is a list of range from 10 to 15, okay, and the data type is float 32. So if you can see in C level, I have this all the 1 values in floating point number, and in the next column D I have an NP array. Here the value is 3 and it will come 5 times, okay, and the data type is int. So you can see this 3 value has come 5 times. And then in the key E I have this categorical, okay, categorical means it will be a kind of list of categories. So here I have this test and train, test, train, train, so it is coming the same way. And then for F I have the string foo. So for all the columns, it is for all the rows in column level F, I have this foo values. And here in the index position I have 10, 11, 12, 13, 14. Why? Because for this C level I have put the index for this series as this list. So this list will generate the values 10, 11, 12, 13, 14. That's why this data frame has these levels. If this part was missing, then it would be some default values, okay. So I can try that as well, how it works we'll see. So let us add one new cell here. So I'll just print this. So here I'll just omit this thing. Okay, as the index is not mentioned, because if I don't give this, so let us have some values. I will give some 5 values here. Let us see, 1, 2, 3, 4, 5. So everywhere it should match. Let us check this. So now you can see that for C column the values is a series of list of values. So 1, 2, 3, 4, 5 has come, and in the index position you can see it is 0, 1, 2, 3, 4 as the index is not mentioned. So why was the error? Because when you are giving a data frame for all the columns, the list of rows should be same. So here it is only 1, that means it will be repeated. If it is a timestamp, it is repeated. Here it is only one string, it will be repeated, but when it is a series, then you have to mention the same number of elements, because for D key we have this array of 5 values. So if I change this, let us say I make it 4. So let us see how it works. So you can see it will give error because arrays must be all same length. So if you don't give the same length, then it will give you error. So I hope it's clear to you. We'll go to the next cell now. So you remember for series we had these D types, but here for data frame also we have these D types. So if you execute this, you can see that there are some For df2, if you see the df2 array, this is the df2 array. So this data frame has 6 columns and 5 rows. Okay, fine. So let us go back. So here you can see that 6 columns are coming, and for each column I have different data types. That I told you that data frames can contain heterogeneous type of data, so that you can see from here. Okay, the next one. Okay, df.head. So these are some functionalities that will be really useful, and we'll be going to use this very frequently. So df.head, this function returns the first 5 records from the data frame. Okay, if you don't mention any argument in between, but if you mention some argument here, suppose I write 7, and then if you execute, so now you can see that you are getting some 1, 2, 3, 4, 5, 6 records, because maximum 6 was there. That's why I can put it as 3. So you can see 3 records. Now similarly, this tail function, it gives you the last 5 records from the data frame. So you are getting last 5. Okay, so if I give 2 here, then you will get last 2 records. Okay, next functionality is index. df.index, it will give you the index values of this data frame. So here it was a date time index. You can remember that there are some 6 dates I had generated, so it is showing here. If you write df.columns, it will show you all the columns for this particular data frame. Okay, so this is another functionality where I can convert my data frame to numpy array. Okay, so if it is a homogeneously typed data, then it is easy to create numpy array, but if it is heterogeneously typed data, then it is going to convert the data type and then it will put it in a numpy array. So in case of heterogeneously typed data, it is time consuming. So let us first create one numpy array from df. If you remember, df is something which is having the same type of data. Okay, we had generated it from the random numbers of numpy. So this is my df. So let us go back. I will execute this. So this is a numpy array, it is created, and you can see that now this array does not have any index or any column values. Now I will try to convert this df2 as well. Let us see. So you can see here that all the elements are now converted, and it is now one numpy array is created from df2 as well. Okay. Next one is this is another very important function. It is describe. It actually gives the statistic summary of data. So if you run, so you can see for this data frame, I can see for a column the count, mean, standard deviation, all these percentile and all important values you can get it from here. So that is useful when you do some analysis on your data. And df.t is transpose we have already discussed. So rows become columns and columns become row, that is transpose. So with df.t you can transpose the data frame. Okay, now again another important functionality, that is sorting. So you can do sorting in many ways. So let us first print it, then it will be more easy. So I will add one cell here. I will write print df. Okay, so let us print it. So this is my df data frame. So first I will do this sort index function. It takes the axis as argument. Axis means this row, it is called the axis 0 and the columns are called the axis 1. So here I have written axis 1, that means I want to sort this based on the columns, and here again I have written ascending equal to false. So ascending equal to false means the sorting will be based on the descending order. So if you execute this, you can see that how it is coming. First the D column is coming, then C, then B, then A, and the row order remains the same. So another statement is here I am doing the sorting, I am calling the sort index function, but here I have put as argument as axis equal to 0, ascending equal to false. So now I want to sort the DF data frame based on the rows, not on columns, and rows based on in the descending order. So let us execute this. So now you can see first the 25th data is coming, and then 24th, then 23rd, and so on. So now the records are sorted based on the rows. Okay, now another way of doing the sorting is based on values. So here I have written df.sort values by, I have put the name of the column as B. So I want to sort the records based on the values of B column. So this is something which we do very frequently when we use Excel, right? So here I want that the entire data set should be sorted in the based on the values of B. Okay, so if you now execute this, so you can see that it is something, the B value, it is the lowest B value, and then so on, and based on that all the values of that particular record of A and C and D are coming. Okay, so that's why here you can see that 21st. So for the 21st record, the B column had the minimum value, that's why this 21st record or row is coming first. So this way I can do the sorting. Okay, now how to retrieve the values from the data frame. Again we have all the options of indexing and slicing. There are a lot of ways I can retrieve data, so I will show you some of them. The first one is here you can see df of A. So I just want to get the values in this column A. So if you execute this, so you can get the list of, it is the index, and all the values in the A column are coming. Okay, next is again it is the slicing. So I am getting from 0 to 2 exclusive. So I am getting the record for the first row and second row of this data frame object. The next one, here instead of mentioning the row positions, I have given the values in the index. So I have given from 20 to 25. So it's coming from 20 to 25 all the records. If I change it to 23 and if I execute, so you can see 20, 21, 22, 23. That's how I am filtering the data. Okay, then these are some another very important function, that is lock, means it will give the based on the location that I have mentioned here. So dates 0 means actually this date, right? So I want the data in this date 0 position. So if you execute this, you can see these are the values which are coming, that are actually for this 28th. For this 28th March, all the columns data, there are 4 columns, so 4 values. So these 4 values are coming here. Okay, then I have put in this log function, I have sent the range dates 0 to 2. So actually I want that dates 0 to 2 means 2 will be exclusive. So for these 2 dates I want the data. So if you execute this, you can see I am getting the data for these 2 dates. Okay, the next one, now in the log function I have sent 2 sets of arguments. The first one is a colon, and in bracket I have sent the list of columns. So here my purpose is I want all the rows but the data only for these 2 columns. So if you execute, you can see I am getting all the 6 rows but only these 2 columns. So I have filtered based on the columns and I am getting all the rows. Next one is here I have put this range for the rows as well, means here I want the data for these 2 columns but only for these 2 rows as well. Okay, so here I am filtering both on rows and columns. So if you execute, you can see 2 rows and 2 columns data I got it. Okay, next one is here I have put only a single date value. So it was a range, it is a single value. So it should be simple. So here you can see that I am getting the A and B column value for only for this date. So you can verify from here, in this date 20th I had two values in A and B columns. Those values are coming here only. Okay, the next one is, again here I am getting the date for a particular row and column. Okay, so if you execute this, I am getting a single value 1.27. So it is for this row and this column. Fine. Then I have this. Okay, this is another new function that is called add function. It is also similar to log, but it is known that it is more efficient than log. So it is also like the same thing. I am getting here date 0, that means the first date, and then the A column. So it is giving me the same value, you can see here. The another thing is ilog. Ilog means the index position. So here you can mention the index position for the row and the column. So if you execute this, it is, you are getting 1 1 1 1 means the first row and first column. So first row and one row, or first row is this, and first column is, it is the 0th column and it is the first column. So it is, this value is there. So I am actually getting this value only. Okay. Then again I have this iadd function, similar to add function. It also works similar to ilog. Okay, so if you execute this, you are getting the same value. Then I have this conditional statement inside this bracket. So here I want to retrieve the data frame where data frame B means the B column value is greater than 0.8. Okay, so if you execute this, you are getting this. For better understanding, I will print df again here. So I will print df. Fine. So let us print it. So this is df, and when I have written dfb greater than 0.8, so these are all the values of dfb. If you see, if I write greater than 0.8 means this value and then this value. So only two values are there. That's why you are getting only two records where the b value is satisfying this condition. So this is also another way of filtering the data. Then I have this statement. So if you execute this, here I have written df greater than 0. That means it is for all the values, it is checking the values which are greater than 0, and it has put only those values in, and in the positions where the values have not satisfied the condition, it has put NaN, so that this structure can be formed in the output. Okay, so I guess so far you are clear. So now another important thing, that now I am going to read some CSV file through this data frame. Okay, so far I have created this data frame from some static data. Now I am trying to read some file, and I have to populate this data frame. Okay, so if you execute this, now you can see I have used the hard.csv file that we have already used. So this head function now gives that these are the first 5 records from this file. Okay, now this d types, you can see that this file has actually these many columns of this data type. Okay, this is very useful because whenever we'll do some data analysis from a file, so first of all we need to keep that data in our data structure so that we can process it. We'll discuss this also in the next sessions as we move forward. Okay, so this info function is also very important. It gives you, this is very important function, it gives you that total how many columns are there, what is the name of the column, how many records are there, what is the data type, and if there is whether it is a null values are present or not. Everything, every information is given with this info function. So with this info function you can have some brief idea about the file that you have just imported. Okay, so here I am trying to do some filtering on this data that I have just taken from the file. So here I have written heart is the data frame object that we have created just now. So heart of age greater than 60. So I want all the records to be put in this object where this age value is greater than 60. So if you execute, now you can see I get these many records where age is greater than 60. So if I just change it to something else, then the number of records should be reduced. So you can see here that I have these many records where age is greater than 70. So all the records, it is actually just the continuation of the columns. So these many records are there where age is greater than 70. Okay, then again, this is just the head function I have used, where I have retrieved the first 20 records from this data frame heart, right? So I can have some idea about this is the data we have in the file. Then I have created another data frame from heart, only taking this particular 2 columns. So if you execute this, you can see that these are the 2 columns. With these 2 columns I have created this data frame. Then I have another data frame where I have taken this column heart slope, and slope value is in, it is another function which is comparing is in 1, 2. That means where slope value is 1, 2, 1 and 2, I am just taking only those data. So if you execute, so you can see this many data is coming, and where everywhere this slope will be 1 and 2. Any other value, if any record with other value of slope, that record will not come here. Okay. Then I have this heart CP I have created here. Okay, these are some of another important function. It is not NA. Not NA means where this is not null value in this CP column. Okay, those records will come. So if you execute this, then I am getting this data where I have some values in the CP. So if there is some null value, then that record will be omitted. Okay, so I guess you are fine so far. So this is the basic discussion on the Pandas data frame and Pandas series objects. So we will continue on that. Thank you for now.